Okay, welcome to another session of Mathspace Academy. I'm going to get started. We're going to go through some quick housekeeping, and hopefully by that time everybody would have joined. Okay, today is lesson 2 of the Mathspace Academy. We're going to be covering the rest of algebra. So we started with some algebra last week. This week we're going to be covering the rest of it, and that's going to include expanding, factorising, and completing the square. Okay, for those who weren't with me last week, who am I? I'm the founder and CEO of Mathspace. And just my history, I'm a math nerd. I really love maths. I was a derivative trader, but then I did well at derivative trading, but decided to leave that and wanted to become a maths teacher when a friend of mine pitched the idea of helping more students than just the students you can teach in a classroom. And that's kind of where the start of Mathspace began. So that was almost 10 years ago now that we started the idea of helping students as they're working through problems, which I think most of you would be aware what Mathspace is. Okay, so we're going to do algebra. Last week, we covered the first 4 subtopics inside Mathspace. This week, we're going to be covering the last 5 subtopics. So it's going to be condensed. We're going through a lot in an hour. So what I'm going to do is I'm going to assume that this is not the first time that you've seen this, okay? I expect that you have all seen and been taught algebra already. And what I'm going to do is really try and go through and maybe to hopefully try and give you a different perspective on it, and also just do some practice and really revision so that we're really confident with it going forward. Algebra is really the key to unlocking a lot of high school maths at year 11 and 12. So you've got to have a really, really good understanding of algebra. It makes your life so much easier. Okay, so like I said, we're not going to cover everything. Hopefully you all have a Mathspace login. If not, ask your teacher. And I mentioned before the chat is on. I might ask a few questions and see how you go with the chat. The Q&A is where you should ask me questions. Okay, I'll just point you that if you do need kind of extra help and detailed explanations, then you can visit wootube.mathspace.co, and all our subtopics, you'll be able to find Eddie Woo's videos for anything that you might be struggling with. All right, now let's warm up, get that brain ticking over. First question of the day, you're going to need this for getting good at factorisation, which we're going to talk about later. So what are 2 numbers that multiply to give 42 and add to give 17? Don't give it away in the chat just yet. Okay, have a think about it. Hopefully you've got your answer. I'm going to launch a poll. Okay, I've launched the poll. I want you to answer in the poll. Hopefully you can all see that. Yep, I'm seeing some answers come through now. All right, I'm going to give you 10 more seconds for everyone to get their answers in. 5, 4, 3, 2, 1. All right, poll's ended, and I'm going to share the results. All right, hopefully you can all see that on your screen. Great, just about everybody got it right. 88% had 14 and 3. So the quicker you can do this multiplication in your head, the better you're going to be when it comes to factorization. So it's really, it helps you so much if you know your multiplication well. I'm going to give one more. Okay, what are 2 numbers? This time it's going to be negatives that multiply to give negative 108 and add to give negative 3. Okay, have a think about it. Don't give away the answer in the chat. I'm going to launch a poll. All right, and hopefully everyone's had time to think about it and can give me a quick answer. All right, poll is launched. 2 numbers that multiply to give negative 108 and add to give negative 3. All right, answers starting to come through. Okay, looking good. All right, 5 seconds. 4, 3, 2, 1, and we'll end the polling and I will share the results. And yes, the vast majority were right, 9 and -12. We had a small number that said 12 and -9. So you had the right numbers that multiplied to give -108. But when you add those numbers, the 12 is the higher number and that's positive. So you're going to get +3. Okay, so these are the kinds of things that you're going to be thinking about when we start talking about factorizing trinomials, which hopefully you're all familiar with. All right, good start, good start. Everyone's got their thinking caps on. All right, now this is going to be our challenge question for today. Now, it's a challenge for us, it's a challenge for me to go through enough of the mathematics that we're going to be able to answer this by the end of today. If you already know how to answer this, then you're probably good to go, and you might not need this session. Okay, so here's the problem. My local council requires that at least 50% of my front yard is grass. Right now, I'm Lebanese, and I know my heritage, my background. I was born in Australia, but my parents are Lebanese, and I think generally Europeans and Mediterraneans, they love their concrete. So this is going to be tough for me. I'm going to have 50% of my front yard grass, right? I would just want a concrete at all, but I've decided to do this nice little pattern that you see here in this picture. I'm going to put a square rectangular garden in the middle with the grass, and then I'm going to put my paving around it. And I want my paving to be the same width all the way around to have this nice pattern, right? Okay, so if my total front yard is 8 meters by 6 meters, and I'll have this perfect paving around the outside, ignore this part here, I want uniform paving around the outside, how wide should my path be so that it takes up 50% of the space? I want to use as much possible concrete, as much concrete as I can, all right? So that's our challenge question. I'm going to come back to it at the end, okay? If you find some of the stuff that we're doing a bit too easy as we're going through and you want to take this away, then maybe take a screenshot so you have the question there. You can start playing around with it. And at the end of the session, hopefully we're all going to be good enough to be able to answer this question, which would probably be a difficult Year 12 exam question, by the way. So it's not an easy question to solve. If you can do this question, you're ready to do, high school Year 12 level algebra and be able to go well in your exams if you can do this kind of question. So, and all you're going to need is some expansion, some factorization, a little bit of equations, which is kind of a little bit going ahead, but I'll be able to kind of fill you in exactly what that is. Not too big a step. All right, cool. So that's my challenge, to get you ready to answer that question by the end. Now, just a quick reminder of probably the most important point that I mentioned last week and with all of algebra is, since the variable x just means an unknown number, that's what x means, unknown number, then anything we can do to numbers, we can do to the variable x. And that's going to be a constant theme when we talk about expansion and factorization. So I always like to think, when I'm thinking about algebra, is, okay, what are the rules with numbers? Because we're very familiar with numbers. So here's a question for you. How would you do this in your head? 9 times 85. Have a think about it. If anyone wants to use the chat to share with others, just click all panelists and attendees and have a think about how you might do that in your head. If you don't have a calculator and somebody's asked you to do 9 times 85. I'll give you just a few moments to think about it. Okay, if anyone wants to write in the chat, feel free to write in the chat, share your ideas of how you might do that in your head. And while you're doing that, okay, good. We got some ideas coming through in the chat. Nice. Nice, right, good. I'm going to visualize it. So if you saw it in the chat, that's the right answers, right? You first multiply by 80 and then 9 by 80 and 9 by 5. This is a really good way to see this in action. just make my screen a little bit bigger. Okay, you can think of it as, if I want to find the area of this big rectangle, the 9 times 85 rectangle, and then all I'm doing is going, okay, instead of making it one huge 9 by 85 rectangle, I'm going to split it up into 2 rectangles, a 9 by an 80 and a 9 by a 5. So that's going to be 5, and then the height is 9, right? So basically, if I wanted to find now this area, instead of trying to multiply 9 by 85 in my head, I can just go 9 by 80 and then 9 by 5. So I'm finding this area, the 9 by 80, and then this area, the 9 by 5. And that's easy to do in your head, right? So that's 9 times 80, or 9 times 8 is 72, and then add the 0 because it's 80, and then 9 times 5 is 45, and then easy enough to add these two numbers, 765. So you have effectively throughout, you know, maybe primary school or early high school, when you're learning multiplication, 2-digit by 1-digit multiplication, you've always been using expansion. You just didn't call it that. You've just been doing it in your head. That is effectively expansion. So if I go back to here, this over here, what you have done, the 9 times 80 plus 9 times 5, that is this. This formula that you learned as a formula, it's actually just natural that you do with numbers naturally. A outside of B plus C is you multiply the A by the B. Let me annotate. I'm sure you've seen this annotation before. And you say, you just do the A times the B and then the A times the C. So you get AB plus AC. And that's exactly what you've done here. You've made the 85, 80 plus 5. And then you've got 9 times 80 and 9 times 5. So that's really all algebra is. Whatever you're doing with numbers, you can do with letters. All right, I'm going to clear my drawings. And let's move on to let's extend this idea now to binomials. So when we say binomials, what do we mean by binomials? Basically just means an algebraic expression with 2 terms. So y plus 3 is called a binomial. Y plus 7 is called a binomial. The binomial is actually the 2 multiplying the 2 together. So let's have a look at this question. We want to expand this expansion idea to where you have 2 terms in each one. Okay. All right, so the area of the figure below is y plus 2 times y plus 5. So the big rectangle here, if that's y and that's y, so that's actually going to be a square, and then that's 2 there and that's 5 there. We want to first, so when we want to work out the area of the big rectangle, we're talking about y plus 2 times y plus 5. Now let's break it up into these smaller rectangles like we did with the other one, and let's find the area of each rectangle. So the area of A is just going to be y times y. So that's y squared. The area of rectangle B is going to be 2 over here, and then that is y. So we're talking about 2y. The area of rectangle C, we got 5 over here and y over there. So we're talking about 5y. And then the last one, the area of rectangle D, okay, so we need to, that is the 2 over here, and that is the 5 over here. So that's just a number, 2 by 5, and that's 10. So if we're now looking at the area of each rectangle, when we want to find the area, instead of saying, okay, it's y plus 2 times y plus 5, we can now look at each of these, y squared plus 2y plus 5y plus 10, because these 4 rectangles, A, B, C, D, make up the whole thing. And so we're basically saying that that's the same as y squared plus 2y plus 5y plus 10. So we found that y plus 2 multiplied by y plus 5 is exactly the same as that. And then, of course, we can simplify the plus 2y plus 5y. So because they're like terms, which we talked about last week, we can add that up. All right. So basically, when we start talking about binomials, we have the a plus b outside of c plus d. When we're multiplying these two together, effectively, we're working out the area of each of those four. We end up with AC plus AD plus BC plus BD. So I'll annotate again and show you. Sometimes people call this the FOIL method, which just means first, outsides, insides, and lasts. But basically what you're doing is just going that times that, and then that times that over here. And then you're doing the same thing with the B times the C and the B plus the D. So that's how you extend this to binomials. Okay, hopefully everyone's following along. I don't see any questions yet, so I'm going to assume that everybody understands what we're talking about so far. And hopefully it's giving you a bit of a visual explanation of what expansion is and why it works and why it just works with numbers, so it must work with letters as well. All right, there are two special cases that you should keep in mind. So the first one is the perfect square case. So this is one where the middle term, so a perfect square basically means a plus b times a plus b. So where we talked about in the last thing, if I go back, a plus b times c plus d, it's exactly the same, except now we're talking about both if c and d happen to be exactly the same as a plus b. Okay, and what happens in that special case is when you do your FOIL, so when you do that multiplied by that, there's your a squared, but that multiplied by that gives you your ab. Then going back this way, b times a is also ab, and then we have our b squared. So that's what we've got over there. So basically what we end up with is this special situation where we have AB and AB together, and that gives us a 2AB that we can combine. So why is this important? You'll see it when it comes to factorization, that sometimes you will see, normally when you're factorizing, you'll have four terms, this a squared plus AB or plus BC plus CD plus the BD. But in a perfect square case, these simplify to make one. So you end up with these three terms, but you're actually looking at a perfect square. More on that in a bit, okay? But that's a special case for binomial expansion. The other special case worth noting is the difference of two squares. So see what happens here. Oh, that's actually incorrect. Let me fix that up on the fly. That is not a plus b squared. It's just a plus b times a minus b. All right. Lucky I picked that up. Here we go. Back to that case. Okay, so a difference of two squares is where you have a plus b times a minus b. And the special thing that happens here is when you go your a times minus b, you get your minus ab, and your b times your a, you get your plus ab, and they cancel out. So you ended up with this binomial to start with. Instead of having four terms at the end, they actually cancel out with plus ab minus ab, and you end up with just two terms. And these two terms end up being the difference of two perfect squares. So more on that again when we come to factorization. All right, time to look at a few examples. Expanding binomials. All right. So let's see it in practice. Basically, we said the first thing you do is you multiply the first term here with the first term there. So we got 10y times 4y. We do the numbers times the numbers, you get the 40. And then the letters, you get y times y, which is going to give you y squared. Okay. Now, the next thing you do, turn on my sketchpad. Actually, let me annotate. All right, so we've now done that times that. The next thing we're going to do is 10y times the 9. Which is going to give us 90y. So we multiply the numbers and then the letters stay as they are. Okay, now this is where it gets interesting. And it's a time where people often start making mistakes, is when you have the negatives. So you have here, you must include the sign that's before that number. So it's -3 times 4y is the next step that we got to do. Okay, and then after that, we're going to say -3 times +9. So always be careful with your signs. All right, so the -3 times the 4y is going to be -12y. And then the -3 times +9 is -27. All right, so we've entered that. We're not done. So Mathspace tells us you're correct step, but you haven't quite finished. Just a reminder, if you're not sure why I'm not quite finished, you can always ask for a hint. And the hint will tell you, yep, look at, you're on this step. There's just one thing you need to do is simplify by collecting all the like terms. And then we have this other hint, 90y minus 12y, 78y. So the 90y and the 12y are like terms. So we keep the 40y squared, but we can simplify that down to 78y minus 27. Okay, so that's the first example. Hopefully everyone's really comfortable with expanding binomials. You got to be really comfortable with it, because when you go factorising, that's when we have to go the other way. Okay, let me clear my drawings. And let's look at our next example. So our next example is one with perfect squares. So remember, here is the case where we have the same binomial expression multiplied by itself. So 4 minus 9m times 4 minus 9m. So you could always just say, okay, well, that's just 4 minus 9m and then times by 4 minus 9m. And that's fine. You do it that way, and then you just do the exact same thing we did before, the 4 times the 4, and then the 4 times the minus 9m, and you just do the normal binomial expansion. That's fine, but there's a quicker way. So if you want to just work on that speed, and if you're in an exam and you want to do some things fast, there's a pattern here that we know that the minus 9m times the 4 is going to happen twice. So all we do is say, okay, the first thing we're going to do is the 4 times the 4 is going to happen. We're just going to square that first number. And then the second thing we're going to do is multiply these two by each other and double it. Okay, so multiplying 4 by minus 9m, again, they always take care for the negative. So it's a positive times a negative. It's going to give us a negative. So multiply them together gives us negative 36m, but then I'm going to double it, okay? Because it's going to happen twice. And you can see that here. We're going to have the 4 times the minus 9m there, and then we're going to have the minus 9m here times the 4. So if you can do this in your head quickly, you can do this all in one step. And then the last thing is the minus 9m squared. Now, because it's you always end up with a positive, because if this is a positive, you're going to get a positive times a positive, and if it's a negative, you're going to have a negative times a negative. So that's always a good thing to check, that the n terms, the a squared and the b squared, are always going to be positive. And 9 squared is 81, and m squared is just m squared, m times m. And so that's our answer. So basically, with a perfect square, we just have the advantage of being able to skip the intermediate step and just go straight to that answer. Okay, which is really helpful just for speed. Okay, and the last one, third one we'll look at is the difference of two squares. All right, I've added a little bit of a twist to this one. We've added an extra number at the front. Okay, so we have 6 out the front, and then 3x minus 4y times 3x plus 4y. So whenever we recognize a plus b times a minus b, Okay, or the other way around, like this, a minus b times a plus b, because it doesn't matter if you say 5 times 7 or 7 times 5. They're both exactly the same. We know that the middle terms are going to cancel out. So we don't have to go through the whole tedious process of multiplying this by this, and then that by that, and then that by that. When we do that, we multiply the 3x. Just use a sketch pad. When we multiply the 3x by the 4y, and then we're going to do the negative 4y by the 3x, we know those two are going to cancel. So we can just save ourselves the time and just say it's a squared. So 3x times 3x is going to be 9x squared. So you just do the 3 squared and then the x squared. And then we don't need to do that middle step because they're going to cancel out. And so it's minus 4y squared. So the 4 squared is going to give us 16, and the y square is going to give us y squared. Okay, so we know that. Now, we still have to do the 6 out the front. So I'm going to put the 6 out the front, and then this thing goes in brackets. Okay, now there is another way to do this. We could have first expanded the 6 outside the 3x minus 4y, which would have given us 18x minus 24y, and then multiplied that by 3x plus 4y. But if we did it that way, we would have lost the benefit of being able to do this really quickly because of the perfect square. So it's definitely a lot quicker to notice that this is a perfect square. And then we don't have to do that middle step. We don't have to multiply bigger numbers. Just go down to that. Okay. So, okay, from here, it's simple expansion where we just have a number out the front. We just multiply by that and then multiply that by that. So that's going to give us 6 times 9 is 54 x squared. Did I mention if you're good at your multiplication, it's going to make factorization and expansion so much easier. There's just so much of it. You know, if you have to reach out for your calculator every time, it's going to end up taking you extra time. And then 6 times 16. All right, a way to kind of do that in my head, I can do 6 times 8, which I know in the top of my head is 48, and then times 2, because 16 is 8 times 2. So 48, it gives us 96, doubling 48. Okay, and there's our answer. Okay, so you see how we could pretty easily do that in 2 steps. If I quickly reset this problem, and we just think about if you didn't notice that it was a difference of 2 squares, then you just did first, let's expand that. Then you go 18x minus 24y times 3x plus 4y. Well, I said 2x instead of 3x. Thank you, Mathspace, for picking that up for me. Okay, and now you can still work this out, but it's just you have to deal with these bigger numbers, and then you have to deal with multiplying at 4 times. So it's going to take you like 3 or 4 steps, 4 or 5 steps instead of 2 steps to work it out. Okay, I won't bother doing that because we already got it the quicker way. All right, here's a little mini challenge for you. Find the value of 605 times 595 by rewriting it in the form x plus y, x minus y. Okay, I'm gonna give you a few moments to think about this. Basically, I want you to work out this answer without a calculator. Okay, you could almost do it in your head if you know difference of 2 squares. As you're thinking about it, feel free to share in the chat if you have worked out good values to choose for x and y to make this calculation easier. If I didn't have a calculator, I would hate to do this like this. I mean, you could. You know, and then do the 5 times the 5 and carry and add the zeros and all of that. That's one way to do it. But now that you know difference of 2 squares, I reckon we can do better than that. All right, anyone got any suggestions on what I'm going to use for the X and the Y here? Nothing in the chat? We want to start with the number X. And then we're going to add something to it. Ah, there we go, coming through now, 605. Nice, very nice. Okay, so 605, because if we start in the middle, basically, we're at 600, then we go up 5, we get to 605, down 5, gets us to 595. So basically, if we just think of this as 600 plus 5 times 600 minus 5. Okay, really easy. But now, instead of, working it out, going 605 times 595, I know something about this that can make it really, really simple, because I know that x plus y times x minus y is x squared minus y squared. So this just becomes 600 squared minus 5 squared. All right. And this you should be able to do in your head. So if you know 6 squared is 36, 6 times 6, and then 100 squared is 10,000, right? You just add as many zeros. 100 times 100, there's 2 zeros in 100. So if we're multiplying by another 100, then we now have 4 zeros. So 1, 2, 3, 4. So we get 360,000. And then 5 squared is just 25. And then this you could easily do in your head. So 360,000, it's going to be 359,000. And we're going to be 25 short, so 975. And nice work, Ashwin, putting it in the chat. Yeah, you sent it to all panelists, Ashwin. So if you put all panelists and attendees, then that'll go through to everybody, so everyone can see your answer. So well done for getting that right. So there you have it, 605 times 595. We worked out how to multiply 2 3-digit numbers, pretty much in our head in less than a minute, really, once we kind of worked out what to do, compared to going through that manual process of the vertical algorithm. And who said algebra couldn't be useful, right? We've used the difference of 2 squares to solve a difficult multiplication. Not difficult, but a tedious multiplication. And that's what mathematicians do. Like that's the beauty of mathematics is you can't have this problem and you're like, oh, it's so tedious and long to do it that way. How can I find a shortcut? And so by being able to manipulate expressions, find equivalent expressions that are just simpler, easier to deal with, that's how you can just have these shortcuts. And that's really what expansion and factorization is. So we're going to move on to factorization. Factorization is just another way of writing an expression. So it's an equivalent expression. And so sometimes it's easier to deal with numbers when they are expanded, with expressions when they're in expanded form. And sometimes it's easier to deal with them when they're factorized. So being able to kind of switch between the two is really very, very useful for mathematicians. It's a shortcut. So factorization basically is the opposite of expansion. So it's how do you go backwards from an expanded expression into something that's factorized, which is basically the binomial expressions that we talked about. So, all right, before I get into it too far, like we did with expansion, let's look at it with numbers first. Let's think about what finding factors of numbers looks like. So, okay, I'm going to go with a simple example here. Let me go full screen on this. Okay, and let me start with just like 12, right? The number 12, we can think of this as 3 times 4. So one way to kind of visualize this when you're thinking about just finding the factors of numbers is, how can you put this into a perfect rectangle? So if we have 12 and we want to make a perfect rectangle that goes 3 by 4, okay? Now, if we had a number like, well, first, that's not the only way you can factorize it, okay? That's not the only factors you can get. So you could have a 2 by 6 rectangle, or you could have a 1 by 12 rectangle, okay? So this is the factors, but generally so there's a few different ways you can factorize. That's effectively what we're doing with these numbers. We are factorizing the numbers. We're finding the different ways, different factors, the 2 and the 6 that make up this number. And then if you had something like a 13, which is a prime number, no matter what you do, you can't make this into a perfect rectangle. It always is just going to be a 13 by 1, okay? Always going to have its 2 factors. So basically with binomial expressions, with algebra, we're trying to do the same thing. We're trying to find, okay, what are the factors? What are the 2 things that can multiply by each other to make this perfect rectangle? So like we saw, so with 24, say, an example with 24, you can have 4 times 6, or you can have 2 times 12, or you can have 1 times 24, or you can have 3 times 8. So we're finding these factors that's going to make this perfect rectangle. So I want to try and give you this analogy now with algebra. So I'm going to show you some things, what we call algebra tiles. And I want us to have this same kind of visualization for what we're doing when we're factorizing. Okay, so let me make this full screen as well. Okay, so I don't know if you've ever seen this. It's probably, I think, new to a lot of you. It's a visual way to think about algebra. So this tile here, I'm going to add it over here. Okay, and that, I'll move it down a little bit. That's my x squared tile. So basically think of this as a square with side length x. So the area of this is going to be x squared. Okay, nice and simple. We don't know how long it is, but we're going to call it x, the unknown number, right? Then this one here, this one's going to be our x. And you can see it's our x because if I put it over here, you'll notice that it's exactly x long, right? This square had side length x. And as for this like little piece, we're gonna call that a unit, okay? So it's x by 1. Okay, so this area is x times x, which gives us x squared. This is x, and it matches exactly against the x. And then that small distance is 1, right? And then this here is our units. So that's just a 1 by a 1. And you can see that because if I put that next to here, you can see it's exactly 1 unit in length. Okay, so I need 1x squared. I need 9 x's, these, and I need 18 of the ones, right? Okay, so let's get 9 x's. 2, 3, 4, 5, 6, 7, 8, 9. Okay, and basically now my total area that you can see here is now x squared plus 9x plus 1 at the moment. Now I need to get that to 18. Okay. I'll leave these here for a second and let's get 18 ones. I really should have chosen some small numbers, but that's all right. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so now we have 18 ones. All right, now what I need to do basically is try and make this area into a perfect rectangle. All right, so I have my X. Now there's two ways I can make these X's. I can put them all over here and then try and get them to line up to 18, or I can turn these around. Oops, let me delete that one. Now I have 19. All right, let me start moving these around. I can turn these around as well, rotate them, and put them under here. So move these over. Let's rotate this. And what I'm trying to do is to get a perfect rectangle. So just like we did with the numbers, we're trying to work out, get a perfect rectangle out of these x squared, 1x squared block, 9x blocks, and 18 unit blocks. Okay, and you'll see if I go through this and I put them all in here together. All right, can you see a perfect rectangle is about to form? Here we go. All right, look what's happened here. We have an x squared, 9 x's, and 18 units. And we have formed a perfect rectangle. So what are the dimensions of this rectangle? Think about the dimensions now. That length is x, side length of the rectangle. That length here, these are all units, right? So it's 1, 2, 3, 4, 5, 6. So we have x plus 6. And then here we have x plus 3. So the x plus 6 times x plus 3, the total rectangle is equal to x squared plus 9x plus 18. Okay, so that's basically, we just factorized it. We found the factors, the two multiples, the two numbers that multiply, or the two expressions that multiply to give x squared plus 9x plus 18. We've kind of worked backwards. Now, remember at the very, very start, I had some questions for you in the poll to ask about factorization. Well, I asked, what are two numbers that multiply to give something and add to give something? How do you work out what are the best numbers to choose here? How did I know to put 6 here and 3 there? The way to do that is to find two numbers that multiply to give 18 and sum to give 9x. And where does that come from? You can kind of visualize where that comes from. Why do I need the numbers to multiply to give 18? Because this extra length here and this, so that's the 6 times 3. That's going to be that last piece of the square. And then the sum have to be 9x. It's that plus that. Okay, so that's where, if you're good with those, with your multiplication, you're like, 6 times 3, that's going to give me 18, and that add up to give 9. And that's basically how you do the factorization. So we'll do one more really quick one with some smaller numbers. There we go. Let's do one really easy, so I don't have to. Okay. All right. So x squared plus 3x plus 2, here's another one. Here, the two numbers that multiply is a 1 times 2 gives you 2, and they add up to give 3. So we put 1 there and 2 here. Get rid of that and that. And there you have it. You have x squared plus 3x, 1, 2, 3, plus 2. And it's just x plus 1 times x plus 2. So hopefully this gives you another appreciation for visualizing factorization. All right, I'm going to go into a couple of quick examples now. Okay, somebody asked the question, is the rectangle the same as the box method? I'm not sure what you mean by the box method, but basically this is just a visualization for how you multiply to give that last number and add to give the middle number. So here's a basic flow to work with factorization. Always start with looking for the highest common factor. That's always your starting point. So let's do a quick example of looking for the highest common factor. So no matter if there's 2 terms, 3 terms, 4 terms, you should always start by looking for a highest common factor. When you're looking for a highest common factor, you're looking for the numbers and the letters. So what's the common factor in the numbers 36, 12, and 4? And the answer is 4. And then what about the letters? Is there a common factor amongst the letters? So we have a Y and a Z. We don't have a Z here, but we have a Y in both of these, and we have a Y in both of these. So that's the common factor. That's how you find the common factor. And then you open up the brackets and you're like, okay, what are the parts that were missing? From the 4Y, initially there was a Z that was missing. From the 12XY, well, I need an extra 3 to get to 12, and it's a -3. And I need the X because that wasn't, we only had the 4Y. And then what did I need to get to the 36XYZ? So to get from 4 to 36, I need my 9. I need my X. Oops, it's a plus 9. I need my X because that's not in the 4Y. And I need my Y. And I need my Z. Okay, I need 1 extra Y. I have 1 Y there, but I need an extra 1. And so that's how you do your highest common factor. The next thing to look at is the grouping in pairs. So when you have 4 terms, then you can do this technique called grouping in pairs. Okay, so grouping in pairs basically just means find 2 pairs and find the common factor of these 2 pairs, and then do the same with these 2 pairs. Now, they don't always have to be the pairs next to each other. Often they will be, but sometimes you might have to say, okay, let's do this pair, this with that. So in this case, 8x and 5z, there's no common factors. So that's the wrong pair. You got to find which pairs have a common factor. So let's try with the first 2. And that gives us, the common factor here, x, y, z. So there's no letters that are common factors, but there is 8 and 10. 2 is a common factor of those. So that leaves us with 4x plus 5z. And then over here, 16xy plus 5z. What's the common factor? There actually is no common factor between 16xy and 5z. So I've chosen the wrong numbers to do together. So then you just try, okay, what's another pair? What if I did 8x with 16xy? Okay, so 8x with 16xy, common factor of 8x, and then it's 1 plus, and then what's left? 2y. And then and then 10yz plus 5z. So 5z is a common factor. And I'm going to start with this one. 5z is a 1, and then I'm left with 2y over here. So notice when you're grouping in pairs, you have to find the right pairs that are going to give us, are going to allow both of these to be factorized. And you know you're on the right track when you see that there's also a common factor here. So we've got this 8x outside of 1 plus 2y. Let me call this 1 plus 2y. Let me just think of it as another letter, d. Okay, so we're talking now about 8xd plus 5zd. Forget about that, it's a binomial expression. Then that's a common factor, right? So we can take it out as a common factor. The d is a common factor. So if I was talking about, let me draw it here. if I was looking at 8x d plus 5z d, then that would be easy, right? To factorize that, I just pull the d out the front, and that'll leave me with 8x plus 5z. So basically, in our case, don't be concerned about the 1 plus 2y being like a double expression, a binomial expression. It doesn't matter. You can think of it's just a common factor. So if, just like I pulled it out the front here as the d, in this case, d is 1 plus 2y, and then what's left? Well, it's the 8x plus the 5z. And so I have managed to find the factors. All right. Okay, we got 8 minutes to go. So I want to go through, let's go a monoquadratic trinomial. And then I want to get back to that challenge problem. Okay, so this was the one that we were looking at with the factor square. So we need to find two numbers that multiply to give the 121 and add to give the negative 22. Okay, so hopefully you know this off the top of your head, that because this is a square number. So it's actually just 11 times 11, which is interesting. So 11 times 11 gives us 22. Now we need it to be negative 22, right? So it's not plus 11 times plus 11. We need minus 11 times minus 11. It still gives us the plus 121, but now adds to give the minus 22. So all we do, basically when you're doing these factorizations, you're doing this. You're just working out x plus something, x plus something. And when you find those two numbers, you just insert them in here. So in our case, it was minus 11. So instead of putting plus, we'll put minus 11 and then minus 11 here. And notice that this is actually a perfect square. So we could also write this as x minus 11 squared. Okay, so the method for factorizing perfect squares is the same as factorizing trinomials. Okay, all right. So hopefully I've gone through enough. Okay, there's a question that's come up. Let's start with, all right, I'm gonna go back to, I'll do questions in a second. Let me do questions first, and then I'll do that challenge question. For anybody that wants to stick around, we might go a little bit over time, but I'll take some questions first. So a few questions. So somebody's asking, I have a school topic test, which is going to be run on Mathspace. I have been informed the lessons do not cover advanced topics or extension work. Could an arrangement be made for extended sets of worksheets covering advanced students? Okay, so on Mathspace, if you have access to, depending on which state you're in, your state curriculum, your teacher should choose the textbook for the advanced. So you will have those questions available. Right now, we're covering just the year 10, or New South Wales, it's called stage 5.2. We're not covering the 10A curriculum. If there is a lot of demand, we will also run maybe an extra class where we cover some of the more advanced concepts. Okay, as for the topic test that's going to be run on Mathspace, so what I imagine your teacher's going to do is they're likely just going to go to the Mathspace textbook and choose questions for you to do in your exam. So the best thing you can do, I might show everybody. So everybody should have access to the Mathspace textbook. And then you can practice all the questions that might come up in the exam on the Mathspace textbooks. So in your curriculum, so again, you might have the 10A one or your state specific one. You can just go into Algebra. If you're doing a topic test on Algebra, what your teacher is going to do is basically going to jump on here. You have access to this, and you can see a list of all the questions. So you can go through any question and say, oh, I wonder how to do that question, and click on that, and then you can try the question, and then you'll just try the question inside Mathspace. So I encourage you to jump on and just do your own practice in your own time. You can also just reveal the solution, and just get a work solution of how to do that. So if you just want a quick like, yep, I get that, I understand that. So you can do this through every single question on Mathspace. What your teacher will do when they're creating a task, you probably haven't seen this before, but all they do is just add this plus button. So if they say, oh, I like that question, they click plus and they build a little test for you. So they're going through and going, I like that question, I like that question. They might choose from like, hey, we're talking about factorising today. They'll go to factorising binomial products. So they chose these questions from one subtopic, then they'll go, oh, I like that question, let me add that in, let me add that in. And then they'll assign it and you'll have your test will basically be the questions on Mathspace. So this is where your homework from custom tasks comes. It's your teacher has gone through and customized which questions they'd like you to practice. So trick for you is do as much practice as you can. You can create by just going to whatever question you want, trying that question, get that practice done, then hopefully by the time the exam comes, you'll be ready for it. Okay. All right, that's it. Hopefully that helped answer your questions. And now we are going to the challenge question. All right, I don't know if anyone's had time to do this challenge question in their own time. Remember, my local council requires that at least 50% of my front yard is grass, okay? I want to make as much of it concrete as possible. So I'm gonna build a path around it and put this little square garden in the middle. My total area is 48. Okay, so let's put this into, let's take all that information and put it into a mathematical model, right? Into a diagram. So we have, that's my front yard there. Okay, I know that that's 48 square meters is the total area of that. And I'm going to have my garden with a perfectly uniform, equal width path around it. So the total area we know is 48. And I want, the council says that 50% has to be grass, right? So if 50% is grass, then what's the area of the grass area? 24, right? So I need to work out this width over here. That's going to give me exactly 24 here and 24 there. Okay, so that width is going to be x here, x there, x there, x there. I'm just going to call the width x meters. And now we're going to use some algebra, some factorisation to go through this problem. All right. Where do we start? Okay, so again, like I told you, this is a really advanced Year 12 level question, but you should know all the maths now to do this yourself. And this is kind of a test to see if you've understood everything from today. All right, let's see. I am going to draw, which color should I pick? All right, let's pick a bright color on this dark background. All right, so if we know that the area was 8 by 6, so we knew that that distance there is 8 and that distance here was 6, which is where we got the 48 from. So we now know that this middle area is going to be 24, half of it. And because we know that the width is exactly the same across each side, then we know we can actually work out that length here. Okay, and also that one there. So going up to the top, we know it's going to be, the whole thing is 8, but then we're going to need to subtract x and subtract another x. So we know that this is 8 minus 2x. And then the height, we know that the whole height all the way up is 6, but then we got to subtract x and x. So we know the height is 6 take away 2x. So we have our area of this rectangle is 24, and we know the length and the width. So we can create an equation from that. All right, so we know that if I multiply the length and the width, 8 take away 2x. Now I put it in brackets because it's the whole thing that I'm multiplying. And I'm multiplying that by 6 minus 2x. I know that that's going to give me 24. And here we have an equation. Now we're getting a little bit ahead of ourselves because we haven't really talked about equations so much, but I know that you have some background on equations that you should be able to follow this. So the first step, we're just going to expand, right? So we know how to expand. We've been spending all our time talking about expanding and factorizing. So we're going to go that times that, and that times that, that times that, that times that. And that's going to give us 8 times 6 is 48. Let me just eraser. All right, 48. Go back to the draw tool. And then 8 times minus 2x is minus 16x. So this should be really comfortable for you to do now. And then minus 2x times 6 is minus 12x. And then minus 2x times minus 2x, don't forget the negatives, gives us plus 4x squared. And that equals to 24. All right, the next step is minus 16x minus 12x. We can group that together, like terms. So 48 take away 28x plus 4x squared equals 24. Okay. All right. Well, we're getting some people answering correctly. Well done. The width is 1 meter. So the next step after that is, so this is where it gets interesting. To solve this, we need to get all the numbers to one side and make it equal to 0. So if I do that, I get 4x squared. I'm going to start with my x squared, then my x, minus 28x. And then plus 48, I take away the 24 to this side. So I get take away 24 is equal to 0. Okay, so I'll explain another time when we talk about equations why we had to do that. But for now, just trust me. The next step is to factorize. Okay, so now you should all be masters of factorization. What is the first thing we do when we factorize? Always, the very first thing is look for the highest common factor. So we say 4 is a common factor of all these things. And then that leaves me with x squared minus 7x minus 6 is equal to 0. Now, how do I factorize x squared minus 7x minus 6? Right, we should recognize this now. It's a trinomial, a quadratic trinomial. So we need to find two numbers that multiply to give negative 6 and add to give negative 7. Okay, and that's why we did our warm up at the start. So it's going to be 6 and 1. One of them is negative, one of them is positive. So I've actually made a mistake. Minus 28x minus 24 plus 6 minus 1. Where did I make a mistake? Minus 12x minus 16x, that gives us minus 28x minus 7x minus 6. 8 minus 2x, 48. Oh, goodness. No, minus 16x minus 2x minus 12x. That's right. Which is minus 28. It's plus 24, not minus 24. Let me see. 4x squared. Ah, of course, plus 24. Thank you so much for fixing up my mistake. All right, good. Oh, we got some clever cookies in this class. So that means that that's a plus. So we need now two numbers that multiply to give plus 6 and add to give minus 7. So obviously they both have to be negative so that they can add to a negative number, but multiply to a positive number, and it's going to be negative 6 and negative 1. So we basically have 4 outside of x minus 6, x minus 1 equals 0. All right, now this is an interesting thing. Hopefully some of you have worked this out, but how do I know how to solve this and why did I make it equal to 0? Basically, we now have three things, and this is the beauty of like why factorize. We have three things that are multiplied to each other that give an answer of 0. Now we know 0 times anything is 0. So we need at least one of these to be 0 to get an answer of 0. So we know that 4 can't be 0, so it's not that. So we either need x minus 6 to be 0 or x minus 1 to be 0. So if x minus 6 is 0, that's going to happen when x equals 6. So if I put x equals 6 there, then this is 0. And then 0 times anything is going to be 0. And then the same thing here. If I put x equals 1 there, then that's going to give me 0. So x equals 6 or x equals 0. Just erase this. Sorry about my poor drawing. X equals 6 or x equals 0. Oh, sorry, or x equals 1. Okay. Go back to my drawing. Okay, x equals 6 or x equals 1. Now, somebody said x equals 1 or x equals 6. And then how do we know which one it is? We know which one it is because if x equals 6, does that work? If this whole distance is 6, then how can this be 6? It's just not going to work because we're going to have 6 here and 6 there. That's going to be 12. The path itself is just going to be 12. So that's how we know that the answer must be x equals 1. Somebody's asked a question about explaining where the negative 24 and the plus 24 came from. So when I was going over here is equal to 24, I made the mistake. I'm trying to move everything to the left-hand side. So I made the mistake of doing 24, take away 48, but I have 48 here and I have to take away 24. So it should be a plus 24. So hopefully that you understand why I just changed it from a negative to a plus. And then that's why we have a plus 6 here and why this works. So there you go. This is, all right, really good. I'm very impressed that a whole bunch of you got this correct. That's amazing. So this is a year 12 level question that would be considered a hard algebra question. So I'm going to say that's a success that we know how to do. And we had to do a bunch of things here, right? We had to do some expansion over here. First, we had to kind of work it out into a diagram. Then we had to do some expansion, some collecting like terms. Then we had to do some factorization, 2 different methods, highest common factor, and then the quadratic trinomial. And then from there, we had to do a little bit of stuff where we had to work out with equations, how we work out the answer from the equals to 0. So that's some pretty advanced mathematics that you all just did there. And you should all be really proud of yourself. If you can just follow this, what went on here, then you're doing really well with algebra. So thank you so much for joining. Next week, we will go through the second topic inside Mathspace. You can find it all on Mathspace, the Academy website. We will be going through next week. Let me get rid of all this annotation, clear all drawings. Linear equations next week. So I think we'll get through that quite quickly. We'll start talking about some graphing. So hope to see you all next week. And thank you so much for attending. Bye for now.